In this video, we're going to see the differentiation of the natural exponential function as a tool to understand the process that we are dealing in until the last video. So the final goal of this video would be just check the final look of the differentiation of natural log function. So let's do it. And let's start with the definition of fx. In this example, it would be natural log of x. Let's see how the form goes when we do the differentiation. So let's use the definition of differentiation. So it would be something like when we converge h into 0, it would be the moment that we spot would be this. So this is the definition of the differentiation. So we just put our function into these two parts. So it would be something like h equals 0, and let's just call it ln x from now on. Ln x plus h minus ln x divided by h. And by the property of log, we can rewrite this as something like this, right? And like this. And it is kind of hard to see, so let's just put 1 divided by h out into here, like this, and it would be ln x plus h, right? And we can rewrite the inside like x plus h plus x, h divided by x, and this would be 1. So we can rewrite this as like this, and 1 plus h divided by x. And when we look at here, right, and here, by another property of log, we can take this as exponential here. So it would be something like, like this, and ln 1 plus h divided by x exponential 1 divided by h. So let's continue. So in this form, we can find the definition of natural constant e. So just to check it again, when it's like this, and 1 plus a, and by a, 1 divided by a, right? And which means when we multiply 1 and really small number, really small number, which is limit a to 0 a here. So it's like 1 point something like that, right? 0 0 0 0 0, something like this, right? Something like this. And we multiply this number because it's gonna go infinite, like infinite times. So that is the definition of the natural constant e. So we're gonna just make this form. So if it goes 0, and we need to reverse it here so that we can make it to go to infinite. So let's say this is a, right? And we want a reverse form here. So it's going to be something like h goes 0 and ln 1 plus a, right? And reverse of a, and reverse of a would be h, x divided by h, right? And we have, what we have here is 1 divided by h. So to make it like equals here, we need to satisfy the equation. So it should be, we can make this, but still to make it same as here, we need to divide by 1 divided by x, so that it goes like this and it becomes 1 divided by h. So yeah, so we made this form, and we know that this part is a definition of natural constant e. So now we take this down here as the property of log. So it's going to be 1 divided by x, and limit h goes 0, ln 1 plus h divided by x and x divided by h. And this part is the natural constant e, so it's going to be, including this part, it's going to be like this. And actually this is 1 because it has the base of this log is natural e, so it's the same that log 10 is equals 1, right? So it goes 1, so we can see that the final form is 1 divided by h. So what we did is, when we get the derivative of log x, the final form would be 1 divided by x. So to see, log x into 1 divided by x. Thank you for watching.